Hello everyone, welcome to this session on IoT and AI Edge. The full name of the session is Offload AI and Analytics Workloads on the Edge. I will try to make this session a little bit more interactive and to ask you some questions also. Hope that it will be also convenient for people who are listening and watching online. So, first, do you have good experience, I mean for the people here, with IoT Edge and Edge Analytics in general? Well, we will discuss the cases, of course, in the level which will be the best match, hopefully, for you. I will try to tailor this session in the best way. So we have several things. Actually, we will talk about Edge Analytics and some specifics there. We will talk about main architectural concept. We will talk more on Azure IoT Edge. Azure IoT Edge, probably, as you know, is a general platform for edge analysis related to Microsoft Azure. It is not only for IoT, but it started mostly from the IoT perspective, and that's the reason to have this name. But it is for any kind of analytics. So don't think that Microsoft Azure IoT Edge is only for IoT. It is a general platform for edge analytics with some specifics to make user experience and developer experience better for people who work with this platform. We will talk about some details regarding architecture, and we will talk also about some specifics when you need to start, because IoT Edge, like platform, is very fast developing solution, and you have every few months some changes. So sometimes it is something which is quite complicated for people to look at the exact latest version and what kind of compatibility we have. These are much more hands-on specifics, which we will discuss at the end. So, first we will talk about Edge Analytics. About Edge Analytics, there are several things which is good to consider. Edge Analytics is not new. Probably you know this. Edge Analytics, I will put this schema, actually is a concept which started first when we have client-server solutions and needed to deliver static content with content delivery networks. It is probably the first general approach to have some kind of analytics functionalities on the edge. We will not go into all specific step historically, because it will take a lot of time. Just what I'm trying to say is that current Azure, not Azure, IoT Edge and Edge Analytics concept is something which is in the context of last 7-8 years. Before, it was actually something which is more related to natural growth of the idea to have distributed load between backend services and what we have on the edge. Probably most of you have experience from the past with different things like fog computer, for example. It is introduced from Cisco, where you have different devices, different servers closer to end user and consumers location, and you have some kind of multi-level distributed solution. But it's too complex. I mean, if you have solutions where you have, for example, servers which are somewhere remote, after that next level of servers which are closer, and after that next, it is something well known, for example, from content delivery network, but for many cases it needs to be more clear and more simplified, and that's the reason actually to go to idea to talk about edge computing, where we have computing on the edge and some computing which is remote in data centers, in the cloud, or doesn't matter how we name this place where are remote computers. There are three important things which is good to know when we talk about edge computing. Privacy. Privacy is one of the reasons to sell edge computing, because if you have some restrictions, doesn't matter if it is up to security or if it is up to privacy regarding to regulations, government regulations, regional regulations, or it is something related to company policies, edge computing works pretty well. There are many solutions, for example, in the healthcare area, implemented as edge computing exactly because of this. And not only. Latency. When you have, for example, need to have immediate response for some event, for example, if you have some anomaly detection, if you have fraud detection on production lines, you need to have immediate response. It is even more urgent if you need to have response from emergency systems for vehicles and different kind of devices where you need to have control. So latency is something which doesn't matter what kind of design pattern we have for cloud solutions, has some physical limitations, because time to send your data to the cloud and back, even in the best conditions, will lead to some latency. So in this case, we need to have edge computing for immediate response. And the third most important feature is reliability. Reliability means that our solution will have much higher SLA and can manage situation where we can have possible interruptions with internet connection, or we have some issues related to deployed in the cloud services. So for important functionalities, it is also important to have high SLA. Having edge analytics, you can provide this SLA, because in any cases, you will be able to have most important functionalities working exactly on the place where you have need to use this analysis. It is, again, something related to manufacturing, automotive industry, airspace, for example. Not only, but these are the most obvious examples where we can have such kind of functionalities. I will go, yeah? Yes, please go. Yes? So from what level of data we need to use edge computing? Thank you for the question. It is very interesting question, which is coming also from the cost perspective and in general from the aspect of complexity of the solutions. When we have edge computing, we have additional advantages which are not mentioned, like these three most important features, but these advantages are also very reasonable to minimize the amount of data which is transferred, and also based on this to make our solutions more cost effective. Why more cost effective? Because in reality, there is statistics. It is not in my presentation, but statistic is that 80% of generated data is not needed to be sent on the cloud. So 80% of generated from devices data is mostly for some short-term usage, and it is needed for some temporary goals. Because of this, we can have in our solutions decrease of amount of data which is sent. Well, it is different for different solutions, but let's say up to 80%, depending on what kind of solutions we have. About amount of data, it is not clear formula for this, but I can explain it in this way. How we can calculate this? We can calculate this based on several things. We need to calculate storage from one side, depends on where we will persist this data. We need to calculate also our processing resources. If in our logic of the solution we process this data, for example, if we are using stream analytics or something, and we pass all this data through streaming process, it is one story. Here we have two aspects. First aspect is how good is designed our solution. If we consider from the beginning that we will have more data on the back end, we will add additional logic there, and we can just persist raw data in some storage. And we can have some logic where to process data which is needed in a specific way. It is up to architectural details, so it could be more or less effort regarding to design and development. But it is not possible to say exactly what kind of amount of data we need. From my perspective, I can say that even solutions which are less than 30-50 terabytes can be considered like solutions where we can have optimization based on data transfer and edge computing. I mean 30-50 terabytes, for example, per year. But it is something which is quite subjective. You can have much less data and again to have some advantages. So my spoke is mostly on general level. If someone wants to have exact discussion about specific solution, I'm absolutely open to contact me, and we can have some high-level calculations and to see what is the advantage and is it reasonable based on specific solutions and case to put additional effort to make your solution as edge analytics solution. There is always additional specifics, because if you need to have on the edge deployed additional logic, you need to have some considerations in your solution. We will talk a little bit later about this because the time for session is limited. I will try to go ahead and to give you several examples. Usually, when we have solutions where we gather data somewhere in data centers, let's say in general on the cloud, we have two general approaches. First approach is when each component is sending data to the cloud. It is pretty similar to commercial solutions where you are buying light, you are buying switch, and all these devices are connected directly to some endpoint in the cloud, and data is collected there. You can control these devices and you can make some different settings. For solutions which are related to home automation and you don't want to invest in additional infrastructure and you have no need of some high SLA and some other things, such kind of solution can be more reasonable. There is specific concept, IoT as a service, and most popular for end users solutions, again I'm giving you example with home automation, are related to such kind of concept. In this case, even if you have some logic, this logic is inside specific device. Usually we have not much logic. Most of the logic is somewhere in the cloud. It is absolutely separate case, and it is very different from cases when we send a lot of data and we need to have probably some optimization and after that to send this data. It is possible also for cases where you can use commercial solutions as explained from me regarding to home automation to have approach with edge analytics. If you have, for example, solutions where you have image recognition, well, someone is coming to your home and you have camera and you have edge device, some board which is running analytics related to image recognition, for example, you have different cases. But depends on specific cases, you can have more or less reason to invest in specific edge analysis. If we have more higher workload and more cases to have analytics in our solution with fast response, then we have higher reason to make our solutions with edge analytics. This is the main general concept for this. And usually when we have edge analytics flow, we have something like this. We have for our analytics data from different sensors. You have on the edge devices one important functionality except the general one for some data processing and analytics. There is needed to have decision which data will be processed on site and which data will be sent directly to the cloud. So in most of more complex solutions, you have this decision as part of the logic of your edge devices. I will go a little further because in general, I would like to cover more things about Azure IoT Edge. We will talk, let's go ahead. We will talk a little bit more about Azure implementation. In Microsoft Azure, we have one pretty well developed solution regarding to IoT. we have a lot of components, and it is not the only one IoT solution which is provided from software vendors, but Microsoft Azure IoT offers more components with specific purpose. What I'm trying to explain, probably most of you have experience, but at least in general, if you get another platform, for example, GCP, partially even AWS, you have a pretty small number of services focused on specific IoT functionalities, and other services are with general purpose, and you need to have configuration and additional implementation to make everything in your specific case as IoT solution. In Microsoft Azure, IoT is with, how to put it, better developer experience, at least for me. You can easily build from building blocks your IoT solutions. And here, IoT Edge is something which is slightly different than just general concept. We have framework where you can deploy containerized applications where you have the same developer experience, like developer experience to use the same or similar services in the cloud. It is the same with cognitive services, it is the same with stream analytics services, with storage, and some other services. I will go a little bit further. We need to consider several additional functionalities related to Edge. I already mentioned reliability, but around reliability, we have additional consideration related to the bandwidth. It is related to the first question from our attendees online. When we talk about amount of data has one consideration regarding to cloud resources and regarding to what we need to put as effort for design. But if we rely on, for example, mobile connection, we need to consider also the cost and limits regarding to the bandwidth. So here we have additional limitation, and it is up to what we want to pay and what is possible to be offered from telecoms in general. 5G now is something which changed the game. In the past, it was consideration because we had limitations, but with 5G, now you have almost no limitation. You have some consideration regarding to the price, but limitation regarding to the bandwidth is almost in history. So, when we talk about IoT Edge features, we have quite often options related to complex event processing. Complex event processing is when we have generation of events from different sources, from different sensors, and you have after that streaming logic where you can have analytics and data processing based on these complex sources, and on the output you can have data with different structure, which is transformed in this way. Next services in your solution to have no idea about these specifics and problems regarding to different sources and how we merge data. It is something which works perfect in Edge solutions. Applications, any kind of applications. I will show you later. Deployment of IoT solutions is pretty similar to modern deployment of mobile apps. you have containerized application which is deployed into your edge devices, and this containerized application is connected to these to backend services. Pretty similar like applications from your mobile phones usually. Here we have one specifics. Depending on what your application is doing, you can follow the good practices to have one common communication channel via IoT Hub. I will show you. And if we have some really high load, we can have separate endpoint, which is good regarding to limitations and price, but not good from the architectural point of view because we are increasing the complexity if we are starting to download data, for example, from different endpoints. There are many details which are interesting. Just because of this timeline for the session, I will go a little bit ahead. I will skip several general considerations and will go to the trends. Here we have several important things in the trends. First is regarding to power connectivity and energy consumption, because edge devices need to consume more energy. In some setup, it is possible, but imagine that you have some devices which are in a remote place and you need to manage how these devices will receive power. If it is some power related to solar panels or batteries, you need to have some good KPI regarding to manage consumption. These devices need to have low energy consumptions. In this case, you need to have the optimal balance because computing means we need energy. From another hand, flexibility of our solutions and where we can use these devices also is up to how much energy we are consuming. That's the reason to have so popular, for example, LoRaWAN and some other solutions which are kind of IoT, because these solutions are using very low energy. Nowadays, Microsoft is working together with hardware vendors to have more optimized energy consumption for edge devices. It is not the best one related to general edge concept because you have framework and you have containers on top, but again, improvement is high. Analytics on the edge. IoT Edge started like framework for edge computing for IoT. But nowadays, most of applications of this framework are not just for IoT, for different kinds of analytics. And security. For security, we have different specifics related to network, specifics related to devices, related to design, and specifics also related to how we can configure everything. I will try to show samples a little bit later. Regarding to Edge Analytics platform, I just added here some of popular, even not all popular frameworks. You see that there are different solutions, especially for me, not like Microsoft Advocate. Microsoft Azure IoT Edge is the best one regarding to developer experience. It is pretty easy to do it. Really, AWS IoT Greengrass is competitive, but again, they have low number of services, low number of components. There are some specifics for specific domains, like, for example, products of PTC and ThinkWorks. It is IoT as a service. Something similar also offer Azure. We will talk probably for this. And you have different choices. But really, world is going in direction where you have building components, you have similar functionalities on the edge and in the cloud, and you have containerized applications that are deployed on the edge. In the past, many other vendors tried to develop own solutions for edge computing and containerized applications. But when big vendors started to offer solutions, actually number of players was decreased because it is difficult to compete with big companies. Regarding to business domains, I even will not go into details, but you have almost everything which you can consider regarding to edge computing. Yes, in some areas it is more obvious, like autonomous vehicles, for example, but for other areas also you have a lot of good options. Now I will talk a little more about architecture overview. We will see after that also some demos. IoT Edge has runtime where we have libraries and models mandatory for normal running of other components. We have also specific functionalities in IoT Edge models. Two of models are very specific and they are in general part of the runtime. One is related to agent. We need to have agent which is responsible for running and monitoring of each of models. And we have also IoT Edge Hub, which is simplified version of IoT Hub. And this Edge Hub need to be used to take all advantages from IoT Edge framework. We will talk about this, of course. When we have models, I will directly go to this schema. You have models which communicate via edge runtime. That means your model has no need to implement specific logic for communication. Your model has no need to add specific logic for security more than what is expected by default. Why? Because all communication is via Edge runtime. Edge runtime has routing functionalities together with Edge Hub, and additionally, for security, you also need to go for any kind of communication via runtime, and also runtime is checking permissions of models to access specific resources. The whole list of functionalities of Edge runtime is related to what I already explained, security, communication, monitoring, and related functionalities. Additionally, it is not something small. It needs to be discussed. We have pretty good intuitive interface in Azure Management Portal to deal with all these components. So you have IoT Edge Cloud interface, and using this interface you can deploy models, restart models, configure models, almost everything. It is possible also to use scripting for this, Bash or PowerShell, of course, and you are able to use SDKs for automation. So it is up to you, but you can start directly with cloud interface, and it is something which is pretty simple, no need to learn additional things. Edge Hub. When we communicate with backend, straightforward approach is to have communication, Edge Hub to IoT Hub. It is technically possible to use different gateway from the both sides. I mean, it is technically possible to use from Azure side different gateway service, not IoT Hub. It is also technically possible to have routing not via Edge Hub, but that means you will lose a lot of advantages, especially regarding to management, monitoring, provisioning of edge devices and models. Because in IoT Hub with cloud interface, you have all these things. We will see after a few minutes. And otherwise, you need to have custom implementation. When we can have need of custom implementation, if we have some very specific requirements for our solution. For example, all modern cloud gateways, including IoT Hub and competitors from other software vendors, are based on one architecture and pattern which is named service-assisted communication. I will not go here into details. You have two different queues, and you have communication between backend devices without direct direction. For example, this leads to additional small latency also because of the pattern. If you need to improve something, and it is very important for your solution, you can have also custom implementation, but you will lose a lot of advantages. If you choose another gateway, cloud gateway service instead IoT Hub, more obvious, you need to have custom also device gateway model, because Edge Hub is implemented in a way to work out of the box with IoT Hub. Again, it is pretty good in 99.9 probably % of the cases. Just I'm explaining some specifics. When we are talking about IoT components, many of components are used for IoT and not only for IoT, and many of these components have Edge versions. For example, IoT Hub has Edge version, Stream Analytics has version, Blob Storage has version, SQL Server has Edge version. We can go into details. Of course, there are more complex solutions like Databricks, where we have no such implementation. Azure Functions also can be run into the Edge. So we have option to simplify our development and to have short time to market with results which we want to achieve. And yes, this is some kind of overall scheme of IoT with devices, and I will not go into many details, but when you have IoT Hub and Edge Hub, one of the good things is that you don't think about protocols. Both devices support the same version of MQTT and AMQP. If you have some custom devices, for example, old-fashioned smart meters or something like this, you have two different options. To connect these smart meters, for example, not directly to your IoT Hub, but to have connection to edge device where to have transformation of the protocol, or you can have also protocol transformation on the IoT Hub. You can have additional service based on IoT Hub SDK here. It is again architectural point, but if you're using edge computing based on Azure IoT Edge, the proper option is to have transformation on the edge. Let's go into this conceptual schema for IoT Edge architecture. Again, we have Edge Hub, Edge Agent. Edge Agent should be always running. Edge Hub is recommended if you are using the default communication, but otherwise you can change it, and modules will be deployed on top of Edge runtime. For modules, we are using containerized application, Docker compatible, but Microsoft chose Mobi framework, like framework for container support, because it is lightweight version. There are no all functionalities for the full Docker framework, just what is needed for your edge devices. And you can have different communication patterns with other devices, and of course you have this option for controlling. How we can have communication between devices and backend? It is similar a little bit with schema for protocol translation. We can have devices with field gateway, which is IoT Edge device. If we are using standard approach, I mean standard for Microsoft Azure IoT, to have IoT Hub, Edge Hub, and IoT Edge framework, we will be able to see our edge devices, and we will be able, even if we have several levels of deployment of devices, if we have no protocol translation, we are able to see all devices and to manage it from our cloud interface. If we need to have protocol translation, it is more tough story, because we will see only edge devices, and we need to have custom implementation about leaf devices. If we have implementation regarding to changing of the names and addresses, we can again manage everything from our cloud interface. And as I explained, you have some common approach for interfaces when we are using Edge framework. Edge agent need to be configured, but by default, if you start, you have no need to think about this. When you start to make some changes, you need to consider also settings for Edge agent, policies regarding to pulling of images, restarting, everything which is related to orchestration of your models. One important simplification: if you are using models, you can simplify the overall logic for your solution. What I mean? Imagine that you have, for example, a solution for healthcare, probably because it simply can be described, or for automotive. And you have different regulation in different regions. Now, I work, for example, on solution for automotive insurance, where specifics are different for US, for Europe, for Asia, and other regions. You can have these differences in the logic in two different ways. You can have universal models with more complex logic and configuration for all regions, or you can simplify this deploying directly modules for different regions. When we make something more universal, usually we increase the complexity. So it is usually simpler when you can, even when you have development, predict this and deploy modules with different specific from advanced into different regions. So you have no need to make additional logic in configuration. You have no need to think if there is some vulnerabilities, exploits regarding to this complex logic. I would like to actually go into a few more details and to show you how you can start work with IoT Edge for the next few minutes. We have a lot of options to which we can run on the edge, and we need mostly to know when we will make some solutions with Microsoft IoT Edge framework, how this will fit to the strategy. Yes, it is more on the high level, but it is important. How we will manage these devices? Do we need some specific security device provisioning? Because IoT Edge framework can use all advantages from Azure IoT, including features like device provisioning, service features, in the best way. You can use stream analytics, for example, also. Well, do we need streaming, for example, stream processing on the edge? If we need stream processing, okay, it is pretty easy. You do everything on the same way as for the backend services, but deployment is done using Microsoft Cloud Interface or scripting, almost in the same way like for backend services. There are some limitations regarding to IoT Edge stream analytics. I will not spend more time. This is something which is improved continuously. You need to also consider for which kind of machines is available IoT Edge. Usually for any Linux based image, you can, with more or less effort, to make even custom setup. But there is list of software implementations, OS implementations, which are supported out of the box, and it is recommended to do it. It is much easier to use IoT Edge with Linux, and 99.9% of Edge devices are actually based on Linux. Windows is mostly for specific cases. You have in logistics and some specific business domains usage of Windows, but Linux is the main platforms. I would like to explain options also to have hybrid, well, aka hybrid solutions. Quite often, you can have also need, because of specific requirements, to have some kind of proxy to your cloud services. It is possible to realize proxy also like additional module for your IoT Edge solution. And I will show you now how to register devices, deployment, and probably this is the most important regarding to the current timeline. Now, it is time for demos, at least to show the most important things when you want to start. Several things. What I struggle when even I started to learn about IoT Edge, and when I need to follow the right versions. First, follow the documentation. You have now several versions of IoT Edge supported. 1.2, which is the latest one, and with long-term support 1.1. There are differences. There are differences also into API, even on the SDK level. So you have latest settings related to 1.2, but depending on what you want, you can have some specifics because 1.1 is with long-term support. When you need to start with implementation, there are two possible options. Even if you want to deploy on real device your IoT Edge framework, I will recommend to start with VM, Linux VM, where the best option is to use from Git actually ARM template. I spent a lot of time to make these attempts to start setup from scratch. It is possible. You can go into details, but you have no need to spend much time. So if you want to start, just use this ARM template. Additional options are if you want to go into custom deployment, in documentation, you can take a look at how you can deploy your model into Linux or Windows machine. Again, there are differences for different versions of SDK, and also differences regarding to Windows and Linux. If you need to know in details how it runs, you can go through this process. Otherwise, you can go into a solution where you just can deploy the ARM template. Let's go into Azure Management Portal. I already have one deployed virtual machine, which is based on this ARM template, and you need to consider, of course, what is the address. It is good for your devices to keep the address, because otherwise it could be possible to manage everything, but you need to use different techniques and additional effort. Let's go on the IoT Hub site. Okay, because we have 2 minutes, I will not try to fix this. I will try to explain what additionally you need to have. When you have edge devices, your IoT Hub has 2 options. Option for not edge devices, and IoT Edge, where you need to register your devices. You can register this manually. You can register this using also device provisioning service. You need to configure all connection and security based on certificates or symmetric key exactly there. after that, you need to configure your Edge framework to use connection string to your device. If it is with certificates, you need to have several steps more. And after that, you will be able to have via cloud interface, via Microsoft Azure, all these options to add, remove, configure, restart different modules into Edge framework. So pretty easy with cloud interface or scripts to make all these functionalities. Yes, we have also some limits regarding to the timeline. If you are interested in any additional details or full functional hands-on demo, please contact me after the session via social networks, email. I will be glad to discuss all details which are interested for any of you. And if you have any questions, I will be glad to answer your questions. No questions for now. Then, do you have any questions from the auditory? If not, I will say thank you very much for attendance, and anytime, if you want to discuss some details regarding to Edge analytics with IoT Edge framework or in a different way, I will be glad to have this discussion and if it is possible to help you. Thank you very much.